In this video, we're going to talk about computer networking and cover Lab 4. The first part of the lab asks you to have a look at the interfaces on your own computer using either ipconfig on Windows or ifconfig on the Mac. And you can do that to have a look at the details of the systems that you've got, and you can use also the netstat command as well. So what we're going to do is have a look at another container, which is network. So I'm going to run that and just do docker run it cyber sits 1003 network, and I have already pulled that, so I have that there. And it asks us to run an ifconfig command, so ifconfig. And if I wanted to, I could do the --help to give some information about what this command will actually do, and also what arguments it will take. But if we do an ifconfig, just without any arguments, we have two interfaces, the ETH0 or ETH0, which is the main address or networking interface of the container. And we can see it's got an IP address of 172.17.0.2. The net mask is 255.255, which means that essentially only those 2 bytes are being used for the network, and everything else is to do with hosts as well. This interface here, LLO, or is the loopback interface. It's actually an internal interface that allows you to access only things on this machine, and it's always given the standard address 127.0.0.1, which is also referred to as the home address. So we see that there are two interfaces as they talk about, and we can use the route command or root, and we get the following table. This actually tells the networking system where to send and forward packets to, depending on the address. The default gateway is to 172.17.0.1, which is going to be Docker desktop running that IP address, and that's where everything will be sent, and then it will decide where to go from there. It asks us now to let us start another container and do an ifconfig. The instructions could be a little bit clearer here, but in another window, let's start that here, and what we can do is do the same thing. We'll do docker run it cyber sits 1003 network, and let's run ifconfig again in this one, and we see that the IP address has changed to 172.17.0.3. So I am running now two containers in this tab and in this tab. It could be run as separate windows. Mac allows you to tab these, so that's fine. So we've got two containers, the original one, which is 17.0.2, and the new one, which is 17.0.3. So this is how the network looks at the moment within this. Now this is running Docker desktop, so this is why this network looks the way it does. On Linux it will look slightly differently. But we've got the gateway device, which is 1.172.17.0.1, and then we've got our two containers 0.2 and 0.3. Now we can actually communicate between these two by using the ping command. So let's go back to 0.2, we can clear the screen and do ping, and -C1, which means only ping once, and then put in the IP address at 172.17.0.3. And you can see it says 1 packet transmitted, 1 received, 0% packet loss, and it will tell you the actual round trip time in milliseconds. of how long it took to get from this container to the other container and then back again. And so that's actually very good. Now we can actually ping our own interface, and you can see that it takes even less time, but it can ping that, and we can actually also ping the home address, which is on 127.0.0.1, and it will ping that as well. Now remember that this is on this container. We can't access 127 on the other container. So going through, we can also ping an address, and this only works with Docker Desktop, which is called host.docker.internal. And that's actually the IP address of the machine outside. So if we do that, ping -c 1 host.docker.internal, and you can see that the IP address of the host has been given 192.168.65.2. If you go into Docker Desktop and go to the dashboard, then if we click on the settings and go into resources and then to network, it will actually give you the subnet that it's set up that is accessed outside, which is 192.168.65, which is actually the address that we have here. It's .2. So that's the network outside. And there's another gateway network called gateway.docker.internal. So in fact, now our network can be built up. So we've got the internal network with our two containers, and then we've got an IP address that communicates with the outside world, or outside of the containers, i.e. the host machine. All right, so the first question is find the other network interfaces. And when you do ifconfig on its own, it just shows you the default ones. We can actually do a -a flag to it, and that will show us everything. Now, this is going to be different if you're running Windows or Linux. This is on the Mac. And on the Mac, we have an interface which is tunnel 0. On Windows, you'll have another interface which begins with an S, sit 0, and the flag asks you to name the interface that starts with a T when running Docker Desktop on a Mac, or S when running Docker Desktop under Windows. So that answers that flag. And we've got some idea of the internals of this. So let's scan the network. Now this depends on what our computer address is going to be, but let's go down and look at the subnet that we found before when we pinged the host.docker.internal, this one. Now we're going to use a tool called nmap, and we're going to use, and so we can use nmap, and we give it the -nn. Now again, we can do a help on this to get a very detailed breakdown of all the things that it can do. And you can see that -nn is a ping scan. It disables scanning for ports, and we don't want to do that. So we're going to do nmap -nsn 192.168.65.0/24. And that means that it's going to try and ping everything in the network from 65.0 up to 65.255, or 254 in fact. It won't try and do 255 because that's reserved. And so if we run that, that will take a little bit of time, but should return the following hosts, which are 1, 2, 3, 4, and 5. Now these are all used for different purposes. It's an internal thing to Docker Desktop, so we're not entirely sure what all of them do. But we will find the following 5 hosts. And we're back. So what we got was the fact that nmap reported that 5 hosts were up. It took 34 seconds, and those hosts are 65.1, 2, 3, 4, and 5. Now we've written a script that does the same thing. And essentially what it's doing is just using the ping command, and you could do this manually. You could do ping and -c1, and basically then just take the IP address, paste it, and it comes back. But what's this doing is doing it from 1 to 254, and it's building up an IP address. And if it finds the return saying, well, if it actually returns true, then it will actually echo the IP address. So if we go to the /root directory, we see ping sweep there, and we do the /, and then we give it the base address that we want it to scan, .168.65, and it's going to append all the numbers, and then we go, and it's very fast, it returns those. One of the things that we've added the argument -w1, which means that don't wait for more than a second, because sometimes when it's pinging, it will wait to ping, and then it takes a long time. But since we found the host that we were expecting, we should be able to Control-C, but it's not going to let us. Never mind, so it'll have to finish. Actually, let's try Control-Z. Control-Z, an interesting command. It backgrounds, it stops the program and puts into background. And now we can do a PS, and we can do a kill 25, and that will stop it as well. Hopefully. Yes, that stopped it. Okay. So we can find the services by using the nmap command, and we can give the arguments -sc and -sv. And so the -sc means run all scripts to find out what the services are that are running, and -sv is to determine the versions of everything that's running. And here it's actually doing this for only the 5 hosts that we found, and it will go through each host and find it. So for this host, 196.65.1, it's actually running on port 53 a DNS server. So that's the thing that's doing the domain translation. So we'll translate host.docker.internal into an actual host. And then there is a proxy server. Don't have to worry too much about that, but that's running, and it will give you some information about that and what type of server it's running. And then I've cut the output of that. Nothing on 2. On 3, there's another service which is called an RPC service. Again, we don't have to worry about it. These are all internal. And interestingly, on .5, there's another DNS on that used for some other reason. So we have a description of all of the things that we actually are running on this network. So the interesting thing is that there are 2 DNS servers, and we can actually see which DNS server it's using by catting a file called resolve.conf. And it can see that it's actually using the .5 name server as the DNS. So when we do the ping to host.docker.internal, it will use this DNS server to actually give it the IP address and return it. Okay, let's look at the question 2, which asks to scan a remote access service. So what we're going to do is run another container called Cowrie. So let's just copy that command. You can click on this, and let's run it in another window. So paste that and run it. Now I've already downloaded it, I've pulled it, and so it's given us some output. Now the interesting thing about this command, just to go over it, is that we're giving it a port argument, which is -p2222:2222. What this does is that we know that there's a service on Cowrie. Well, I'm telling you that there's a service on Cowrie that runs on this port 2222. And what we want to do is make it accessible to things outside the container. And to do that, we map it to 2222. And so that means that we can access this from outside the container using that port mapping. So this is running, it's given us some output, and we can have a pretty good idea of what it's actually running, because we can see in the output it says Cowrie SSH factory running starting on 2222, and that means that essentially it's running SSH and it's ready to accept SSH connections. So they have a pretty good idea about what that's doing. But let's go back to the other container and let's do a scan. So there's a hint here if you want to actually use the hint, and that gives you the nmap command, but that's okay. I think I can manage to remember it. So we use nmap, and we're going to run all scripts, so sc, we're going to detect all versions, sv, and we're going to output the -v to give us a bit of debug output. So that means it prints output as it goes along, and we want to actually scan everything from in this network. So let's do that. But I have a pretty good idea that it's actually going to be 0.3, because we know that when you run a second container, that's the IP that's given. So just to make this quick, let's just go to 4, and we can run that. So it's actually found 2 hosts, which is sort of interesting, and there's a technical reason for why this happens, but it's found 172.17.0.1, which has this port, 111 on it, which is RPC, that don't have to worry about that, but it's found the 222 OpenSSH one. It's also found on this thing just the OpenSSH, and in fact these are 2 IP addresses that are linked to the same host. So actually, if you try and connect to either of them, it will succeed. But let's just concentrate on this one. We know that this is going to be the Cowrie one as well. If we go back here, the interesting thing is that Cowrie has detected that it's been scanned and has put a great deal of information out, and so basically you can see that it's got a new connection from SSH, and you can see what nmap has been trying to do. It actually connects to the SSH service to find out the version, and the version of SSH that's running is OpenSSH 6.0 P1 Debian, and that's the version that is detected. So we know it's 172.17.0.3. Let's try and connect to it. We're going to use the SSH command to do that. And actually my terminal has messed up. Let's just try a reset, see if that helps. SSH, and we're going to give it the port command, because SSH is normally by default on port 22, but we've moved it, so it's on 2222, and we'll give it a username. Now we don't know the user that's running on Cowrie, but let's just guess and just say it's root as well, and we'll do root at, and then 172.17.0.3, and let's have a go. Oh, okay, this is sort of interesting because I've run this before on this host, and the fingerprint has changed. So normally you get asked, and we'll show you how that works, to verify that it's a known host. Because that's changed, it's saying, you're connecting as possible man in the middle, and you don't want to connect to this, so it won't let us. Now it's actually saved all this information in this file here, so what we can actually do is copy that and just remove it. Okay, so if we now try that SSH again, it doesn't know anything, it's recreated a known host, and now we get that message that you will probably see, which is the authenticity of this can't be established. Are you sure you want to continue connecting? And you say yes, and then it asks you for a password. So there's 2 ways of connecting to SSH. One is using a certificate, so you can use a private key to do this. And in the project, there's one of the questions is around that, or you can use a password. Now, we don't know what root's password in, but let's just assume that a password wasn't set and just hit return. And guess what? We've got in. So there we go. We're now in Cowrie. Now, Cowrie is a honeypot, and so it's allowed us to connect, but everything that we're going to see in this is is essentially fake. But you can see the output that it's sort of detected the connection and sort of seen that we're there. If you're running this honeypot for security reasons, then you'd be very interested in the fact that somebody's trying to SSH onto the honeypot. So we can do an LS here, and there's nothing very much, but I think we are told here to, once on the machine, look at the file, etc. password. So if we just cat that, we get the flag at the bottom. But I'm going to blur that out, so you will need to do this yourself to actually get the flag. And that is it. Until the next time. Thanks very much.